Hi, everybody. Welcome back to Shiko Math Practice Lab, Learning Through Practicing. This is a new unit. In this unit, we're going to talk about the integrated by parts. And I have five parts for this unit. And basically, we're going to talk about the 5 different function form and the skill we use to try to do the integrated by parts. So for the first practice, we're going to take a look at the integrated by parts. If your function is a multiplication of the polynomials and exponential, or is a trig functions here. So those are type of the problems I'm going to show you how to do the integration by parts. And also, I'm going to show you how to use a tabular form to do it, which to me, I think is way easier and it's way more organized, and the chance to make error is a lot less here. Okay, so then we're going to talk about the different ways. So how about if your function is an exponential and the trig function is multiplication, then what do we do? Okay, so now I think it will be, good time to pause your video and then go to get a pen and a pencil and try to work those problems out. And then later resume the video and let's check the answers and to see you got it right or not. Okay, so now I'm going to go to the whiteboard and you can pause your video and then later when you are ready and resume it. Hi, welcome back. Welcome to the whiteboard here. Okay, so before we do the problem, I do need to review few very important, like the basic integrations formula with you, and then it will make this section is very efficient and effective, okay? So the first things here, I hope that you all still remember, right, from your fundamental integrations. So let's take a look. If I have e to the ax dx, so how do I do the integrations for the exponential functions? And so I hope that everybody remembers, so the exponential will be the e to the ax. Because you have a constant, so it will be divided by a, and plus, of course, a constant c. And also for the trig functions here, so for example, if you have sine ax, right, dx. So what is the integrations here? Because I also have the constants here, right? So the integration, I hope you all remember, this will be the negative of what? Cosine ax, of course, divided by a, the constant. So the same way, when you have the cosine ax here, dx, okay, so then the integrations here will be what? Will be sine ax divided by a and plus c. So I hope those kind of you still remember. If not, maybe you need to go back to review the u substitution to know how do you get this. And also, I want to review another things is what is the integrations by parts, right? So basically, the integration by parts here, let me put all the formulas in the blue color. Okay, so integration by parts, basically you try to integrate some function, and then you'll be able to separate inside your integration sign to two things here. One is u, another part is what? Another part is v's, right? dv is here. That's why we say it's integration by part. Then based on, so you take the derivative, dv, you take the integration. So the formula will be the uv minus Then here, this is dUs here. So like I think your teacher will probably teach you here, which one is u, which one is dv. Probably you want to choose the one when you take the derivative, it's kind of going to reduce the term. Then the dv, you want to choose the one, it's easier to take the integrations, right? Okay, so that's basically the formula we need in order to do the integration by parts. So let's try to practice here. So let's try to start with the easiest ones here, right? And so this is y, this is e for the point 2y dy. Like I told you before, one is going to be u and other one going to be dv's here. And also I'm going to show you is the tabular forms here. So which make the, I think to make the integration by part way easier here. So here, for this column, I'm going to put what I'm choosing for u, and from this column, I'm going to choose what to put for dv's here, right? Okay, so in here, the y, I'm going to use the color coding, maybe a little easier. So then here, dv's here, I'm going to put this is e pointer 2 y. So remember, this one is you take the derivative, right? And this one, what? You take the integrations, right? Okay, let's try to see what happens here. Okay, y, you take a derivative will become 1. Then 1 is a constant, you take a derivative will become zeros, right? Okay, so you stop at a 0. Okay, now the dv is e to the point 2y. So remember the formula we just reviewed. So the integration, so this will be 0.2. Then this is e point 2y. Okay, so you do the integration one more time. Okay, so this 0.2 will just be constant. So you do that one more time. So what happens here? You have a 0.2 to the what? Square, right? So this is e 0.2y. And because, okay, so in here, and because we have, this is minus VDU. So this is the most important. Some people forget about it. So you do plus, minus, plus here. You always start with plus, so you alternate plus, minus, plus. Okay, now let's see what is the final answer. You go this way and this way here. All right, so the final answer for this one's here, it will be y times e for the 0.2y, 0.2. Then this is a minus, right? So this is a minus, okay, 0.2 to the square e to the 0.2y. Of course, don't forget plus c's here. So if you want to simplify a little bit, this 0.2 in the denominator doesn't look too good, you can change that to the integration, the integers here. So this is a 5y e to the 0.2y. Then the 0.2 square is kind of like a 25. Then this will be e to the 0.2y plus c, right? So that's pretty easy, right? So like when you try to do the tabular form, that's why I kind of like it. And it's a very organized way to do it. Okay, now let's take a look at the b's here. The b here, this is x minus 1. And then here, this is a sine pi x dx, right? Okay, so let's still do the same way because this is a polynomial and the trig. So let's do the same ways here. Let's use a table. Okay, so in here is my u column and this one is my dv column. So, okay, so let's take a look at my u column will be x minus 1. Then my dv column will be my sine pi x here. Okay, so now one side to take a derivative, my green side to take a derivative, my pink side I take integrations here. Okay, so x minus 1, you take a derivative will be what? Will be 1, right? And then 1 is a constant, you take a derivative will be 0. Okay, now let's take a look at the sine pi x, right? So remember the formula, I just reviewed that. So sine, you take the integrations will be what? Cosine, negative cosines, right? So this is a pi. So we'll give you negative cosine pi x, right? Now you take the integration again. So when you take the integration again, so this pi just constants. So you have a pi square. Then the cosine, so this negative sign still there, correct? Then cosine will be what? Sine pi x is here. Okay, then you stop. Okay, then the last step here, you put your signs, plus, minus, plus, right? Okay, now the answer will be here, here. Okay, so let's try to write it out. What is the answer? So the answer will be negative x minus 1 cosine pi x over pi. Now here is negative, negative is what? It's a plus, right? It's a positive. So it's a pi square sine pi x. Of course, don't forget plus c here. All right. So the now this is what is the, we said is integration by parts. Okay. So now let's take a look at the next problem here. Let me go to the next page. Okay, so that is the problem C here, right? So we still do the same way. And so this is the t square sine beta t dt here. As you can see, this is a polynomial with some trig functions here. So we can use the tabular form. Okay, so let's use the tabular form. And so here is the tabular form. Okay, so one side is my u and one side is my dv's here. Okay, so as you see, it's very consistent. It's always the same way. So this is my u, it's a t square. Okay, so now here, this is a sine, what? Sine beta t is here. You know, like this way, you know, like this one's here, if you use like the long form, it would, you know, will become very tedious, and the chance you make a mistake for the plus minus signs is very big. So I really like the tabular form. Okay, so now the t square, so this will be the derivative is 2t's, right? Then 2t, the derivative is 2's, right? Then 2, when you take a derivative, is what? It's 0's, correct? Okay, now this is what we're going to this sine cosine things. Okay, sine integration is negative cosine beta t. Don't forget the betas here, correct? Okay, now cosine integration is sine. And the beta here, you move one more beta down, so it's a beta square. So this negative sign is still there. So this is a sine beta t. Now you do again. So what happened here? So this is a beta cube, right? So sine, you know, you take the integration will be cosine, negative cosine. You have a cosine here. So what here is cosine beta t is here will become positive. So you just need to be very careful about the positive, negative. And now you start here as plus and minus, right? Okay, now here's the answer. You do, right? So right now you have 3 terms. So now let's try to write it. So what is this one's here? Be very careful, right? So this is a negative t square cosine beta t over what? Over beta. Good. Then it's a minus minus become what? Plus, right? So minus minus, so this will be 2t sine beta t and beta square. Then here plus plus, okay, so plus 2 cosine beta t and beta what? Beta cube plus c, right? So it's a pretty straightforward and easy to do. Okay, so now let's take a look again, and let's try to do part D. I think pretty soon you will be very good at it. So the part D is here. This is z to the cube ez, right? dz. So, well, you see, hey, this is another polynomial with what? With exponential. So we say, okay, so let's do the tabular form. See here. So we put this is the u, and this is the dv's here. So what is my use here is z to the cube here. Now what is my dv? This is EZs, right? I really like the Z part. It's kind of pretty simple. Okay, so now let's take a look at the derivative. Z cubed, this will be 3Z squared. Then this is 6Z, and this is 6, and this is 0. Now, the EZ part, okay, so the integration of the EZ will just be the self EZ, EZ, and EZ. I like this. Make it a problem a lot easier. Okay, now be careful about the plus minus. So start with plus, minus, plus, minus, plus. Okay, now let's see which one times which, right? So this one, boom, 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 boom. All right. So now let's try to write out my solutions here. So my solutions will be, okay, so be very careful, right? So it's z to the cube EZ. Okay, so there is a minus, right? So minus 3z to the square EZ. Okay, there's a plus. So it's a plus 6z plus 6z EZ. All right. Then minus 6ez plus c. All right. So it's pretty cool, all right? It's easy and very organized. The chance to make the mistake is very small. Okay, now let's take a look. E's here. So this is here, I'm going to say this is x, sine x, and cosine x dx. Now you say, oh boy, I have 2 trig functions here. What can I do? Well, I like those tabular form, and but I have 2 trig function. So in here, in order to use this table form, I need to combine. I need to combine these 2. So I'm going to use the double angle formula. So if you remember the sine 2x, this is a double angle, right? So this is 2 sine x, cosine x. So I know I can rewrite this. So sine x, cosine x is what? Is half of the sine 2x dx, correct? All right. So now what is the next things that I can do here? I can move the 1/2 out. So this 1/2. Okay, I'm sorry, here we have the limits, 0 pi, doesn't matter. We just till the end, we put the 0 pi to the end. Okay, so this is 0 to the pi. Then now this is a sine x sine 2x dx. Then you say, yahoo, okay, here we got a polynomial. And what do we have here? Here we have trig functions here, right? So now I can use my nice tabular form. Don't worry about this 1/2 here, right? So I can have here, I put a u here, and I put a what? I put a dv here, right? So u will be x. And what is the dv? This is a sine 2x here. Okay, u, x derivative is 1 and 0. Okay, now let's do one more time integration. We did this so many times. So sine integration is negative cosine 2x divided by 2, right? Okay, so the then cosine integration will be, cosine is sine, right? So this negative sign is still there. So it's a sine 2x, but you need to times another 2 on the denominator. So this will become 4, right? Okay, so now don't forget, and then we start a plus minus plus, right? Okay, so then here go boom, boom, like this. Okay, so my final answer will be what? My final answer, don't forget this 1/2 in front, right? So then you will have like 2 negative x cosine 2x, correct? Then plus, minus minus become plus, right? Plus 4. And what is here? This is a sine 2x, correct? Okay, very good. And then my limit is 0 to pi. So you can just substitute the 0 and the pi in there. So this will be 1/2, right? So this is 2 negative pi cosine 2 pi plus 4 sine 2 pi, then minus 2, 0, cosine 0, plus 4 sine 0. So here, right? So finally, the answer here is negative pi over 4. Okay, so it's pretty cool. Okay, so now the last one is a little bit harder, but it's not bad. Okay, let's go to the next pages here. Okay, so the next page is here. So last one's here. This is the problem F here. I'm integrating t cosecant square t dt is here. Okay, so you see, oh, okay, so I have a polynomial. I have a type of the trig functions. Maybe I can, use the tabular form. So let's try. Okay, so here, so this is a u, and this is my dv's here, right? So let's do the same way. So this is a t, and dv's here is cosecant square t. Okay, so derivative t is equal to 1, and 1 the derivative is equal to 0. Okay, so now the only part of this one's here is, okay, cosecant square. I know the integration of the cosecant square is negative cotangent t's, right? Because because the cotangent, the derivative of cotangent is negative cosecant. Okay, now the only hard part is what is the cotangent integrations, right? So that's why I'm going to put it separately in here. So the cotangent integration dt, oh, well, they use t, I use dx, that's fine. So then here, cotangent is what? It's cosine x, sine x, dx, right? That's the cos. Now I can use the u sub. I will say, hey, u is equal to sine x, right? Then I have a du equal to cosine x dx. So what happened to here? So this one, I changed to what? Du over u. So what is this one's here? So this one, the integrations will be what? Natural log u plus c, of course. Now what is the u? C is here, is the sine x here, right? So now I know the negative cotangent integrations here. This will be the natural log, negative natural log sine t. Like I said, this is the only one. It's a little bit harder because the cotangent integration is not that obvious, right? Now, after we do that, it will be pretty easy. It's plus, minus, plus, right? Okay, then you go here and here. Okay, so now let's write it out. What is your final answer? Okay, so this will be negative t, cotangent t. Okay, negative plus, right? So this will be plus natural log sine t plus c. All right, so that's it, right? So we did 6 problems, and this is our first pattern. So if your function is the form of a polynomial multiplication of the exponential or trig function, then this tabular form is very, very handy. And personally, I really like it because it's very organized, and the chance to you make some silly algebra mistake is very small. Okay, so our next video, we're going to talk about how about your function is the multiplication of the exponential and the trig functions. Then how is this tabular form works? Okay, so it's nice to talk to you today. So don't forget, practicing, 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 right? That's the way to get better in math. Okay, so I'm looking forward to talk to you in our next video. We're going to talk about another skill. If you have exponential and the trig together, what do we need to do? See here. Okay, you have a good day. See here.